So today I'm going to do the other part of our 21.3 notes, so we'll call this 21.3b. So we did the mean of the sampling distribution of the sample proportion. Now we're going to do the mean of the sampling distribution of the sample mean. So we're going to be using the sample mean this time, and we're going to use instead of your sample proportion, which was the 40%. So for a random sample of 50 boxes, what interval centered on the mean of the sampling distribution captures 99.7% of the sample mean? Well, first thing I need to know is I need to know the mean of the sample. That's what we've got up here. The mean of the sample. It's going to be equal to the mean of the whole thing. And the mean of the whole thing is 323 grams. So there's my mean. I'm also going to need to know the standard deviation. So, to find the standard deviation of the sample, or the standard deviation of the means of the samples, I have to find, or I have to use this formula right here, use the standard deviation of the whole thing over the square root of the number of items in our sample. So the standard deviation of the whole thing is 20. And we're talking about sampling 50 boxes. So if I go to my calculator for that, 20 divided by the square root of 50, that gives me a sample standard deviation of 2.828. We'll call that 2.828. So I like this number 99.7 because if you remember when we first learned our bell curve, we know that the mean goes right here, that within here is 68%, within here is 95%, and within here is 99.7%. So I need to find the interval from here to here. In other words, I'm going to take the mean and I'm going to subtract the standard deviation once, twice, 3 times. And then I'm going to take the mean and I'm going to add the standard deviation once, twice, 3 times. So if my mean is 323, let's find the value on the left first, so the subtracting one, minus 1, minus 2, minus 3. So I'm going to subtract 2.828 3 times. Well, what's another way of writing I'm subtracting it 3 times? Well, to do this, to multiply it by 3. So 323 minus 3 times 2.828. Minus 3 times 2.828 gives me 314.516 is what I get. And then the other side, I'm going to add the standard deviation 3 times, so that would be adding 3 times 2.828. So 323 plus 3 times 2.828 gives me 331.484. So what is the interval centered on the mean? Sorry, that's the SSR bell. So this is telling me that 314 point whatever that was, 516 is down here. And up here is 331.484. That's my interval, is from 314 to 331. So I'm going to say my answer would be between 314.516 and 331.484. Now don't stress too much about the decimal places. I will tell you what to round it off to. And if you're slightly different, it just is a rounding issue there. I wouldn't stress too much about that. Even my answer here to Miss Armstrong's answer, it's a difference with the way we're rounding things on our calculator. So don't stress too much about that. We will deal with that as it comes. So the next example then says, What is the probability that a random sample of 100 boxes has a mean mass of at least 320 grams? Now again, these problems are different than these ones. These ones always use the word proportions. This one doesn't have the word proportions anywhere. This time we're changing our n value. It is no longer 50, but it is 100 this time. And I need to calculate my standard deviation again of the sample means. That would be the standard deviation of the whole thing over the square root of n, which in this case is 100. So that means I have 20 over square root of 100 is 10, which means my standard deviation is 2. Okay, so what I'm going to do is I'm going to convert this 320 grams to a z-score. So to find the z-score, I'm going to take the number of interest, which is my 320. I am going to subtract the mean, which was 323, and divide it by the standard deviation, which is 2. And when I do that, 320 minus 323 divided by 2 gives me negative 1.5. And now I got to find my z-table. That would be negative 1.50, so negative 1.50 would just be the first one. So 0.668. Okay, so there's my z-score. And this is saying the mean mass is at least, meaning that the least value, or the smallest number, is 320. In other words, they want to know greater than or equal to 320 grams. So this right here, I wrote that wrong, it's 0.0668, meaning that it's 6.68%. Now remember, from our z-table, that tells us the amount below. So the probability of having a mean mass of less than 320 is this, 6.68%. Greater than 320, I have to take my 100% and subtract the 6.68%, and that gives me 93.32%. So at least means they're wanting to know greater than. At most means they want to know less than. So if they say at least, we have to do the 100% minus. If they say at most, we just take the number straight off the table and turn it into a percent. Okay? Because you can't get the probability of an exact point, they can ask for between, calculate both z-scores, and subtract from the table numbers. We know how to do that. That's kind of what we did over here. All right, so your homework tonight is the same page as last night. It's in your textbook, page 825, and I did put the page 825 assignment on the School Loop locker so you can look at that. Tonight you're just going to be doing numbers 1 through 9. Please do it on a separate piece of paper than last night's homework because it will be counted as 2 separate assignments.